Hey guys, so today we're going to be solving the problem climbing stairs. So the problem states you are climbing a staircase. It takes n steps to reach the top. Each time you can either climb one or two steps. So we know that at each stair we can take either one or two steps. And the question asks, in how many distinct ways can you climb to the top? So for example one, they said if we know that the number of steps to take to reach the top is two, there are two distinct ways in which you can climb to the top. So the explanation is you can either take one step twice or two steps once. So I'm going to elaborate on this. Yeah. So now for this example, know that each node/circle is going to be a stair and each edge is a step. So we're going to start from step zero. So at step zero, we can either take one or two steps. So if we take one step, we get to step one. At step one, we also have the decision of taking one or two steps. So if we take one step again, we get to the last stair, which is stair two. So this is one unique path. So now let's go back to stair one. So if we take two steps from stair one, we see that we reach stair three, but stair three is not a valid stair. If we take stair three, we're going to fall off. So we say this is a zero, this is not a unique path, so zero unique paths, right? So now you may be wondering how we'll get the number of unique paths of stair one. So the number of unique paths of stair one is just the sum of the unique paths of stair one and stair three. So if you sum this value together, 1 and 0, you're going to see that you're going to get one unique path. So let's go back to stair 0. So for stair 0, we've already made the decision of taking one step. So we can now make the decision of taking two steps. So if we take two steps, we see we are at the last stair. So that is another unique path, one unique path. And to get the number of unique paths of stair 0 to the last stair, which is stair 2, you just need to sum the number of unique paths of stair 1 and stair 2, so which is two unique paths. One thing you may notice is that we encounter stair 2 twice. So instead of calculating this value again, you can think of it like, oh, we can store the value somewhere. So you can remember like, oh, when we're at stair 2, we already know the number of unique paths, which is 1. Yeah. So now let me code up the solution. So this is a DFS problem. This problem whereby we're going to have int n, which is the last stair, and int stair, which is the stair we're going to be on. So we know that if the stair is greater than n, is an invalid step, so we return 0. If the stair is equals to n, it's a unique path, so we return 1. So if we have seen the stair before, let's say we have an array called stairs, and if we have seen the stair before, if the value is greater than or equals to 0, we're going to return, instead of going through all the paths of those stairs, we're going to return it again, return those values, because we already know we've already traversed that path. And we are going to think of int path as going to be equals to DFS and which is stair 1, which is when you take one step, and we're going to sum it with DFS and stair plus 2 taking two steps, and we're just going to return the value with on path. So this doesn't exist yet, so we're going to make it so it's a private integer, this, which is going to be called stairs. So stairs is going to be equals to new int and size of it. What else? So we're gonna have to fill, because we're going to fill the array with -1s, because it initially creates the array with values of zeros, and I need to check for this. Stairs, comma 1, and yeah, so return DFS n, comma 0. Let's see. Let's see this. Will it work? Oh, public. Well, int. Run. Submit. Time limit exceeded for 44. Why are we using memoization? Still is greater than end. Still is less than end. Oh no, that's not the problem. I'm not storing the answer. Yeah, I am not storing the answer of the paths. So yeah, instead number of basically what happened was that I wasn't storing the number of unique paths from each stair to the last stair. So yeah, and this should work. Oh, variable name path. Yeah, and that's the solution. Yeah.